So hello everybody. What we're going to be doing today is finding the extreme values of this function of two independent variables z. So how do we go about doing these types of problems? So what we want to do first is we want to take the partial derivatives of z with respect to x and with respect to y. So delta over delta x, this is how we write down partial derivatives. Instead of d, we put this strange delta. So is equal to 2 times y minus 6x, okay? 2 times y minus 6 times x, and the partial derivative of z with respect to y is equal to 2x minus 4y. Okay, so the next thing that we have to do is set these two values, these two partial derivatives, to 0. And now what we have to do is solve this system of equations. So how do we go about solving this system of equations? Well, it's pretty simple. So from the first equation, we have that y is equal to 3x. Y is equal to 3 times x. And from the second equation, and we can rewrite the second equation as x minus 2y being equal to 0. So when we plug in this value into this second equation, we get that x minus 6x, that x minus 6x is equal to 0. So from here, we get that x must be also equal to 0. And when we plug in that 0 right here, we get that y is also equal to 0. So this is the only possible solution to this system. So we've got a stationary point, let's call it S, with x and y coordinates 0 and 0. Okay, the next thing that we have to do is we have to find the second partial derivative of z with respect to x, which is equal to -6. Then we have to find the second partial derivative of z with respect to y, which is equal to -4. And then we also have to find the mixed derivative, or this. So we take the first partial derivative with respect to x, and then we differentiate it with respect to y, or we can just take the first partial derivative with respect to y and then differentiate it by x. In both cases, we'll get to the same result. So basically, we get that when we differentiate this here part with respect to x, that the mixed derivative is equal to 2. And now let's call this A. Let's call this C. Let me just separate that a bit. So C is equal to this, and let's call this b. Okay, we'll just say that this is b. So what we have to compute now is called, let's call that what we have to compute now as d, and that's going to be equal to AC, and that's going to be equal to AC minus b squared, which is equal to -6 times -4 is 24, minus 2 squared, which is just 4, which is equal to 20. So if we get that d is greater than 0, then that means the function has an extreme value at the given okay, it's not really given, at the calculated stationary point S. Okay, and because this A right here is less than 0, that means that the set extreme is a maximum. If A were to be greater than 0, then that would mean that the function has a minimum in that stationary point. Okay, now that we've actually found the point at which this function has an extreme and it's a maximum, so Z max is at S0, 0. Now we have to find the actual value of Z max. So once we put in these x and y values into our original equation, namely this one, we'll get that Z max is equal to 10. Okay. Yeah, and of course, if A is less than 0, if D, is less than 0, then the function doesn't have any extremes. In any case, this value encompassed in red is our final answer to this problem. So I hope you've enjoyed the video. If so, hit that subscribe button and give a like. And give the video a like. I hope you enjoyed it, and goodbye. I'll see you in the next one.